pi times radius, so 3.14 times 5 times 5, 25 times 3, whatever, 76 point something or 75 point something. So whatever that answer comes, as soon as this return comes, this will be replaced by whatever that number is. Okay? And then that number will get stored over here. Everybody agrees?
Yes.
So how many lines of code we needed to call this function? 2 lines of code, right? However, if you take a look at this function, you will notice it's totally self-contained, meaning this function does not use any data inside the class. Okay, so let's pretend even if I declare something double, let's say d1 equal to 2.3. Okay, so I could have variables declared over here, but is the code in this function using this variable?
No.
No, so it's totally self-contained. To call this function, we do not need any memory inside the object, right? Okay, so to make our life easier for those cases where the function does not use any data inside the class, we have the static keyword, okay? So in this case, what we will do is we will add an extra keyword over here called static, okay? So the minute we add static over here, we do not need, this is not the way we will call the function, so this will not work, okay? Because it's static, meaning totally self-contained, our code will now, calling code will look like this. Radius equal to, so name of the class, which is my compute, dot, name of the function, which is compute area, and then whatever parameter you wanted to pass it. So you can see now we only need 1 line of code to call the function, which previously we needed 2, okay? So once again, anytime you write a function inside a class which does not rely on whatever variables you have declared inside the class, mark it as static. This way the caller can call it in 1 line of code rather than having to create an object of the class, okay? So that's the benefit of the static method. So it makes calling code. So static is always applied to a function. Sorry, it can be applied to a function or a variable, applied to a function or a variable inside a class. Okay, I haven't discussed the variable static yet. So anyway, if you mark the function as static, it makes the calling code basically single line. And once again, it will go as name of class dot name of function. So that's the syntax for a static function. Okay, so now let's modify things a little bit. What if I did this? I marked it static, right? But instead of putting pi over here, okay, suppose I also have one more function over here, public static double compute volume, okay, double radius. Okay. And suppose I said, so again, double pi equal to 3.1415 and return 4 divided by 3.0 multiplied by pi multiplied by radius multiplied by radius. Remember, it's 4 over 3 pi r cubed, correct, is the volume. So now we have 2 functions inside the class. both are marked static. Okay, so first let's check this. Is it legal or is it okay to mark this second function static?
Yeah.
What's the requirement for a static function? That the function should be totally self-contained.
Self-contained.
The code over here should not
No, it's not.
use any data declared inside the class.
No, it's not allowed.
So is it totally self-contained?
No.
To call this function, do we have to go use any of the data declared in the class?
No.
No, so static should be okay, right? Because it's static, how will somebody call it? Name of the class, dot, name of the function. So what's the name of the class? MyCompute, dot, what's the name of the function? Compute volume. Suppose somebody wanted to call it with a radius of 3.0, and because its returns are double, so now we can store the result something like this, double volume. So one line of code will end up successfully calling this function. Everybody agrees?
Yes.
Okay. Now, see, whenever we write code, there's a concept called refactoring. Okay? All good programmers will write some code, then they will refactor it later. Refactoring basically means to organize it so that we are cleaner, writing it less lines of code. So as soon as you develop this function, then a few days later you added this function, you'll realize you're repeating a few things. Okay, what are we repeating over here?
Pi.
Pi. Okay. So what you will do is you will say, oh, you know, why should we declare here again, declare here again? So let's do this. Let's move this double pi and make it the variable inside the class. Okay? So as soon as we do this, then of course we won't write this line, we won't write this line, because this pi now will come from here.
It will go. Static.
So now will the static keyword make sense over here?
No.
Now see, this pi over here is using the data declared inside the class. So this code will not even compile. You try to run it, it will give you a compiler error that it is using, that this is a non-static field. So this is the error you will get, that your static method is using a non-static field called pi. Okay. So this is where, as I mentioned, the static keyword can be applied to a function, or it can also be applied to a variable. So in this case, what we'll do is, because the value of pi does not change no matter how many objects of MyCompute we create, whether we create 1 object or 100 objects, value of pi will always be the same, right? So now what we'll do is, we'll go over here and further add the keyword static to the variable. So once we add the keyword static to a variable, think of it this way, that all objects of this class will share this variable. Meaning there will be a single memory for no matter how many objects of MyCompute you create, there will be one single memory for this particular variable. So if you have 5 objects of it, all 5 of them will be pointing to the same memory for this variable pi because it's marked static. Okay? So now it is okay to use a static variable inside a static function. Okay, so it is okay to use static variable inside a static function. Okay, so now this is okay. This is also okay, and the code is a lot better because we're not repeating this declaration of the pi in each and every function, right? So everybody follows the static keyword. Okay. So anyway, as I go to the computer, maybe not this lecture, but next lecture, I will give you a few more examples so that you completely understand when to use static, when not to use static. Okay. So now let's come to the next three keywords, which are extremely important for us to understand. Once you understand when you will use abstract, when will you use virtual, when will you use override, then the understanding of the basic object-oriented programming will become a lot easier, okay?
So this is called refactoring, but what you just did.
I refactored the pi to appear as a single data inside the class so that we don't have to repeat these two lines. So these two lines will disappear, and that's called refactoring. Okay, now let's go take a look at these three concepts. They are a little bit harder, so pay special attention. Because once you understand those three concepts, the rest of our learning of basic object-oriented programming will be extremely easy. And I'll give you a warning, even some of the really good developers often do not know what's the difference between these three things, okay? So even if you've been programming for a while, take a look at my explanation and hopefully you'll be able to understand it clearly, what do these mean, okay? Okay, so anyway, so now we want to clarify virtual, abstract, and override. Okay, all of these have to do with inheritance. Okay, so in fact, actually, this will be a lot better if I went to the computer. So let me go to the computer and because then I can copy and paste the code and save a lot of time. Okay, so in a minute, once the okay, so hopefully you guys have all obtained Visual Studio. And once again, you know, unless you've been programming for a while and you think whatever we have covered so far is too basic, if you are, let's say, not as confident in your programming, whatever I create in the class, make sure you go home, open the computer, and try to recreate it. That only then you will become better at programming. So just watching and reading will not make you a better programmer, okay? Okay, so first of all, we created a project last time. Remember, I forgot we called it first or something, right? And remember, I had put it in a folder called CS440 something fall or something, right?
CS440.
So there's a couple of ways to open that same project so that we can modify it. One is you launch Visual Studio, and then you go File, Open, Project Solution. So you'll go to File, Open Project Solution. Okay, then go to the folder. So in our case, it's C drive and CS440. Fall 2015. So I'll double click on this folder. Okay, here's the first, right? I'll double click on it. Once you see this file called SLN, this is called the solution file. Okay, and solution already contains a project inside. So this is what you open to get back to what you were working on before. So you open the solution file, the SLN file. Okay, so remember, this is what we had done last time. We had created a student class. So if I double click on the student class, show you, here's the student, and we had the 5 fields, first name, last name, and so on, right? Okay. And we had this one method, compute grade, okay? So now let's pretend you were creating some kind of a university application. and you wanted to, and let's pretend this, whatever 5 fields we created represent an undergraduate student, okay? Now we wanted to represent a graduate student, okay? So if I go right click on name of the project, so not the solution, but the project, right click, and choose add, new item. Okay, I'll pick a class so that I can create a class for a grad student. So I'll pick a class and let's call this grad student. And remember, class names start uppercase, no spaces in between, no underscores, grad, G capital, student, S capital, right? And a class, and make sure it's C#, okay? And click add. So we'll create just a skeleton for the grad student class, okay? Now again, we will declare some fields over here, right? And some functions over here. So let me ask you what kind of fields we need for a grad student. Will a grad student have first name?
Mm-hmm.
Yes, last name.
Mm-hmm.
ID. Let's also pretend grad student will have test 1 and test 2, okay? Now let me pretend grad student will have 1 extra field called thesis, okay? So 5 fields will be the same as a student, but 6th field thesis will be extra. Okay, so if I'm typing this code, what will I do? One option is I will do string first name, right? Then I will right click on it, refactor, encapsulate field, right? So and I'll delete the extra line. So same way I will add the second property, third field, fourth field, fifth field, sixth field, right? Okay, or what's the other possibility? You will say, oh, 5 fields are the same as the student. So you will go over here to the student class and you will start copying, highlighting and copying this part, right? So let me copy all the 5 fields. In fact, let me copy all the 6 fields. I mean not the 6 fields, meaning the function also. Let me copy everything, okay? So I'm copying the inside of the class. Remember, what does this curly indicate? End of what? Class. End of namespace. So above the last 2 curly braces and starting from student first name. So I'm copying the inside of the class. Copy, and I go to the grad student and I paste it, right? And then I needed 1 extra field, so let me go above this and I can declare, let's say, string thesis. And if I right click on it, refactor, encapsulate field, okay, so now we have the 6th field, right? So how much effort did we put in over here as far as adding or creating the grad student class? It was really typing 1 line of code and copying and pasting the other, right? So first, let me give you a guideline. Anytime you're copying and pasting and developing code, you are a poor programmer, okay? Good programmers never copy and paste, okay? So again, gradually you'll see why, okay? So because there are many things common with the student class over here, this is where we use inheritance, okay? So, so let me delete all of these things. And let me just leave the compute grade just for the sake of saving time. So in the student class, I deleted all the fields, okay? And just kept the compute grade, okay? And over here, now what we'll do is we will inherit from the student. So this colon student basically means inherit all the fields, all the functions from the student class. So this is how we indicate inheritance in C#, which is exactly like C++ but different from Java, okay? So anything that was in student class is available over here. And what does that include? First name, last name, ID, test 1, test 2. We can add an extra field. Okay, so in inheritance, you can add more fields. Okay, but you cannot delete an inherited field. So in other words, if you wanted to say I don't need test 2, okay, you cannot do that. So you inherit everything. You inherit all the functions, all the fields, okay? You can add more fields. So in our case, we wanted to add thesis. So this is what it will look like, string thesis. And now I will right click, refactor, encapsulate field. Okay. Okay, so now you will notice, so 2 more minutes and I'll stop. Okay, let me at least finish this part. You will notice it's not recognizing test 1. Okay, it's not recognizing test 2. Where were these declared? Were these declared in the grad student class or the student class? Right? And remember, it's test with a T lowercase. So let's go to the student class momentarily and see how did we declare the test 1 with a lowercase. Is it public or is it private? Private. Default is private in C#, so that means outside of this class nobody can see it. Okay? But because student and grad student are closely related, what if we wanted to allow grad student which inherits from this class to be able to see this test 1? Okay? Then just like Java, C++, we have a protected keyword. So protected once again means derived class, meaning a class that inherits from us can see this. Everybody else will not be allowed to see it. Only the class that derives from us will be able to see this, right? Same way over here, we can mark it protected. So this is same as Java, same as C++, no difference over here. Now, 1 more minute, if I go back to the grad student. Okay, so now you can see it recognizes the test 1, test 2, right? Okay, so now we have one small complication. There's a compute grade inside grad student. And let's pretend for a grad student we wanted to give 50% of the weight to the first test, 50% of the weight to the second test, okay? If I go to the student class, what does the compute grade look like? 40% of the weight to test 1, 60% to test 2, okay? So, however, as you can see, it may get confusing. Which compute grade should we use? If we call the compute grade, because there are 2 functions, both are called compute grade, right? Because this we are inheriting from student and changing the code. So anytime we inherit and change the code, in C# you will use a keyword called override. Okay? So that basically means we inherited it. Okay, but we are changing the code. So again, to prevent any confusion, C#, if the same function appears in the base class, meaning the class from where we are inheriting, because this appears in the student class, this code we are writing is in the grad student class, right? To avoid any confusion, we are saying we are overriding whatever we inherited, okay? So anyway, same way I'll talk about abstract and virtual next time. Okay, once you are done creating any project, okay, remember you need to save it. So anytime you build solution or try to run it, it automatically saves it. Okay? All right, we'll continue from there.